Hi, this is Ilka Cassidy with Passive House Accelerator, and thanks for tuning in to the special bonus episode of the Passive House podcast recorded at PhiusCon 23 in Houston, Texas. And a big thank you to Solar Windows for their support of the series. Hi, Lisa. Welcome to the podcast. I'm very excited to talk to you today. First, maybe can you introduce yourself and let us know what you do?
Yes, sure. I'm Lisa White. I'm the Associate Director at Phius. What that means kind of depends on the day, but kind of oversee our training. I spent a lot of time at Phius with the project certification review process and development of the standards, some of our new research efforts, so kind of touching all ends of the organization, but mostly helping our team get what they need to succeed.
Awesome. And I heard there are some changes coming up.
Always.
Always in 2024.
Yep.
Before we get there, could you explain the evolution of the Phius standards?
Sure, yeah. So really it goes back to 2015 when the first climate-specific standards came out, when Phius developed that. So we made our heating and cooling performance targets climate-specific, just depending on where you were, your heating and cooling load and demand targets changed. And quickly we realized that not only does climate make an impact on that kind of optimal point in investment in passive measures, but also building size. So in 2018, we ran more of the cost optimization studies looking at different building sizes and using that as also a proxy for what those targets should be. In 2021, we added basically the range of sizes that we study. We added a tiny house. So we looked at, what if you're in a really, really, really small building? Did those optimizations we ran before really fit that? So we needed to kind of extend the curve of the sizes we studied. So we added the tiny house, and we also added factors for density of occupancy and units for multifamily, because that also, again, has an impact on the energy balance and kind of those optimal points. For 2024, for our new construction standard, or our base standards, Phius Core and Phius Zero, there's not a lot of changes happening. We actually feel 2021 is working really well for new construction. I'll talk about retrofit later. But we are making adjustments based on some of the additions, or I guess revisions to the International Mechanical Code for ventilation in some areas. So we have to kind of follow what the code is doing to make sure the ventilation rates in our studies are matching or aligning with the code, because that's what people will be required to do. So it's minor tweaks really in the weeds. So 2024 for new construction will look much like 2021.
I did notice on your website that you added a principle to the 5 passive house principles.
Which one?
Shading?
I mean, yeah, it's always about optimization of solar gains. So that's a combination of, picking the right glazing, the right solar heat gain coefficient, the right amount, or if, based on the amount of glazing, you need the right gain coefficients. But then, of course, optimizing, using passive strategies to allow the solar gain when you want it and block it when you don't.
Yeah. No, I just noticed that, because that's definitely something that I run into quite a bit, where it's great to have a certain solar heat gain coefficient, but sometimes you have to be able to control it.
Yep.
So, and I think it's great that there's more focus on that, and not just looking at what Wolfie says, right?
Oh, yeah.
Because sometimes Wolfie doesn't really tell you, depending on where overheating might happen.
Right.
But just in general, saying gains are great, but you have to be able to control them.
Absolutely. Totally critical. Yeah.
So what's next on the retrofit side?
Yeah, so we're really excited to hopefully early next year launch what we're calling Revive 2024. So our existing retrofit program is Revive 2021, very similar to our new construction program. The 2024 Revive really takes a whole new perspective and framework for passive building retrofits. The main 2 things to know is that now, instead of cost optimization to determine how far to go with your enclosure, the thermal performance of the enclosure, we're using resilience as a guiding principle. So essentially what we're doing is we're looking at different packages and requiring that these buildings maintain a certain number of hours above, certain set points or certain temperatures during grid outages, during main grid outages. And we're studying that for both winter and summer outages. So we're kind of looking at these critical design weeks and ensuring that the building does indeed remain resilient without power. And that's telling us how far to go with the enclosure.
Oh, that's really important. What does that mean on the modeling side?
So totally new tool. Yeah. So that's part one. But from a modeling perspective, what that means is that we now need more sophisticated simulation tools, or we need a nice, simple, user-friendly tool that runs on a more sophisticated engine with hourly simulation capabilities. So we are building that tool in-house right now. I imagine we'll end up expanding with partners as this gets more, more public and more used. But that does mean WFI passive in its current state will not be used to assess that resilience metric. But we're building that. We're trying to make different packages. And then the second part of that is if you can find different enclosure packages that work to meet those resilience targets, but we'd like to minimize the total life cycle cost of that retrofit. So some of the motivation for that was thinking, if I retrofit this building, I need to make sure it costs less, including the cost of operating it and carbon emissions, embodied, operational, than if I didn't touch the building at all, right? We need to make sure that we're minimizing that total cost over time and, putting our dollars and our emissions in the right place, So that's kind of part two of the standard, and we call that right now the adorbed cost, the annualized decarbonization of retrofitted building cost. And it's a combination of 5 things: the cost to operate the building, the cost of the carbon, the social cost of carbon for the operational the operational emissions from the building, social cost of carbon of the embodied emissions that go into the materials, and then also the direct cost of the retrofit, right, the materials that go into it. And then the last one, kind of unique, is the energy system transition cost. So if you're electrifying a building, you're adding more electric load to it, how much grid capacity in whatever form needs to be added to the grid to support that peak? So it's kind of trying to think about how the peak load of the building really impacts the overall system.
Yeah. No, I think that's a great approach. And you're very into modeling all the grid availability, and how does that work?
First, I'll say that there's not really enough tools out there to really encompass all of the things that we want to study. They're getting there. This past year, we released a report. We were funded by the AIA Upjohn grant to study the kind of relationships, and synergies between passive buildings and microgrids, or really low-load buildings and microgrids. And for that, we use the REOP tool. So with the Phius standards, we use BOPT, Building Energy Optimization, NREL tool, looking at our optimization within a single building, right? Upgrading the building, looking at saving cost, saving energy, saving cost over time. What REOP does is it's renewable energy optimization. So you're actually coming to it with the building load already and setting an objective or a project goal. And that could be basically just financial optimization, or it could be resilience, so maintaining some sort of critical load during a grid outage, or it could be some like decarbonization. It could be an emissions reduction or some sort of percentage of renewable energy utilization on site. And what you do is you come to it with the building load, your objectives, and then you set what you will allow, or what you'd be willing to put into the system. So let's say it's PV, on-site PV and energy storage. You could also say wind. You could also say diesel generator or something like, there's a lot of options. But what you're doing then is saying, I need to meet XYZ objective with this building load. What system capacity do I need of these parameters that I chose? Mm-hmm. So the work that we did was really looking at electrifying an existing neighborhood in Milwaukee. If we kept the existing building enclosures and wanted to go to, let's say, 100% emissions reductions, 50% emissions reductions, what would we need from a systems perspective to meet that objective? Versus if we first upgraded the enclosure, wanted to meet that same exact target, 100%, 50% emissions reductions, whatever it is, what kind of system capacity would we need from that, from a perspective of solar and storage? And the results are jarring. I mean, it's not linear. It's exponential. Once you look at reducing the peaks in the building, has such a dramatic effect on what we need on the other end in terms of, it was limited. I was just looking at solar and storage, but it's really, really dramatic when you just reduce loads in the building first, how much easier everything fits into place.
Yeah.
So
Yeah. No, I think it's great. And I think it's great to have a tool that can show that, because I feel like now, especially in Europe, there's so much talk about systems all of a sudden, about heat pumps, and the whole envelope first approach kind of fades away a little bit. So it's really important to actually have tools that can show how important it is.
And this one is just kind of scraping the surface, I'll be honest, because what it can do is look at that, okay, I have this load I need to meet, and this is what it requires in terms of the power generation and storage. But what it can't do right now is look at the interrelationship between the individual buildings and sharing energy between those, or potentially orchestrating loads at different times to actually reduce the total system capacity that's needed. Yeah. Right now it's looking at, okay, aggregated all these different building loads in the neighborhood, but they're not responsive to when power's available versus when it's not. So there's no grid interactive capability there. They're not able to shed or shift load based on knowing there's high emissions right now. So that element of it is really just missing. Yeah. We tried to simulate some of that in Excel, basically by looking at hourly emissions and looking at loads and trying to shed some stuff. And there's a lot of potential there, but the tools aren't ready for it. They're not. Yeah, they need to catch up.
Yeah. And last question, a tool like Woofy, for example, it's a comparative tool, right? It's not necessarily an absolute tool, because you have to set certain parameters that are not always necessarily responding to the occupants. So the tool that you're talking about, is that similar, or is that actually an absolute tool that you can use to really predict?
React, no, is not. Woofy can be adjusted to, predict more of the occupant use, but when you're doing a project for Phius certification, we have to just assume the occupant is the same occupant no matter who you are and where you are. Yeah.
Which is really important, because otherwise there's no way to compare.
Correct. We're certifying the building, not the person. Unfortunately, we should certify the people, right? Phius certified occupants. No, and REAP doesn't really do that either, but I think the future of getting these connected devices, I don't think I personally think leaving the occupant out of it might be best, but having devices and algorithms and a setup where the devices know when to shed load, when to shift load, based on some sort of signal. So it's all kind of happening in the background, and the most important thing, I think, for that to be successful is that the occupant doesn't even notice. You don't want to make it so it's like, there's a lot of emissions, turn your heat down, and then the occupant's cold. Like, you don't want the occupant to know it all, in my opinion. You need deliver the exact same outcome, but in a way that uses less emissions.
Yeah. Awesome. Thank you so much.
Yeah, you're very welcome. Thank you for giving me the opportunity to talk today. I appreciate it.